We're going to start by going over with question number 1. And again, I'm going to be using a sticky note because you can't see my screen. I'm going to tell you what I see as far as my sticky note. Okay? For question number 1, it says that which of the following best describes angle DE? When I take my sticky note, and the good thing about the sticky notes or the pieces of paper is they work really well even on your computer screens. You can just put them right up to the screen and see what the angle is. So in this case, put my sticky note, match the vertexes, the corners, and I can see one of my lines, but the other line gets covered up by the sticky note. The angle is too small. So what kind of angle is it? What kind of angle is it if it's too small for the sticky note to fit? Chase? It's an acute angle. If the angle is too small, when I put my sticky note there, if one of my lines is perfectly on one side, the other line is covered up, it's underneath my sticky note, then I know that I have an acute angle. The angle is too small for my sticky note to fit. So for number 1, my answer should have been D. Question 2. Which of the following best describes angle JKL? And they give us a little hint on it, but I'm still going to check with my sticky note. I'm going to match my vertexes, my corners, and that fits perfectly. What kind of angle is it when my sticky note fits perfectly? Jaylene? Oh. Mm-hmm. Yeah, like I said, I usually leave it open for you guys to have a second chance, but once we start going over it, like right now, we can't take it again and try to fix our grade, because again, I'm telling you guys what the answers are. And it wouldn't be fair to everyone who tried to have someone wait, get all the answers, and then go back and get 100. But usually on the tests, and like I've told you all before, I'll leave it open for you. I'll let you put in and go back and try again to try to fix your answers. But for right now, I'm just using it to show you all what the answer should have been. So Nakai, you say you know. I check with my sticky note, and my sticky note fits perfectly in the angle. What kind of angle is it, Nakai? It's a right angle, which means that for question 2, my answer should have been H. And I want you guys to know this. A lot of times, maybe not every single time, but a lot of times on math problems, if they show you an angle and it's a right angle, they might put a little box here in the corner. If they put a little box there in the corner in the vertex, they're trying to give you a hint or a clue that it's a right angle. So if you see this little box in the vertex of an angle, start thinking to yourself, that's probably a right angle. You can always double check, and it's not like it's going to hurt you to double check. I've never heard of anyone going and double checking an angle and their finger falls off, or their arm breaks, or all their hair falls out or anything. It's not going to hurt you. You can always double check, but if you see that corner, see that box in the vertex of the angle, they're giving you a hint. This is a right angle. And here's exactly the same thing. They gave us a square, told us that this is a right angle. Okay. Number 3. Which of the following best represents parallel lines? Who can remind me? Parallel lines. We have to have 2 of them. But what is special about parallel lines? Ezekiel, what was special about parallel lines? No, we already did it. We're just going over it so we can see where we made some mistakes. But who can tell me parallel lines? What's special about parallel lines? Jada? A little bit louder, Jada. Perfect. They can never cross. Even if I took the lines and I stretched them out forever and ever and ever, parallel lines can never cross. They can never touch. If I look at the ones for answer choice A, I might say, oh, they're not touching yet, but look how close they're already getting. And remember, in math, they put these arrows to let us know the line's going to keep going that way. And if these lines keep going, line Y and line Z, they're going to end up running into each other and crossing. So they're not parallel. Answer choice B, I can already see my lines touching. So it can't be answer choice B. And the same problem is what I have with answer choice D. The lines are already touching. I can see it right here. There's only one set of lines for this question that even if I stretch them out forever and ever and ever, they wouldn't cross or they wouldn't run into each other. That's answer choice C. I can see that they have space between them. They're not getting any closer together on either side. Never gonna run into each other. So my answer should have been answered. This question could have been a little tricky. How many acute angles does a right triangle have? We talked about triangles before. What is a right triangle? Because I mean, we know what a triangle is, but what's a right triangle? What is special about a right triangle that makes it different from just a regular triangle? Who can tell me what makes a right triangle different from just a regular triangle? Doesn't have to be a tent. But what makes a triangle a right triangle? Well, we'll get to that one too, Nakai. Let's look at that name. Right triangle. Earlier, we had a right angle. So there's something similar there. Right angle, right triangle. So why do they call it that? What is a right triangle? Violet, what's a right triangle? Oh, what's your question? Right now, baby, it's not PE time. It's not our focus. I want us to focus on math, especially because there were a lot of tricky problems on this question, or sorry, a lot of tricky problems on this test. But if you still have that question, when we go to PE today, you can ask Coach. Haley, make sure we're paying attention and not just playing around. Find a place that's comfortable, but pick one place because I don't want you to keep going back and forth, back and forth. Nadine. Okay, so right triangle. I can make one here. A right triangle is a triangle, like the name says, but what makes it a right triangle, this would be a right triangle here. What makes it a right triangle is that one of the angles in the triangle, one here, is a right angle. So a right triangle will always have one right angle. Just one. Can't have more. Now, when we were talking about triangles, we also learned something else. No matter what kind of triangle you have, whether it's a right triangle, whether it's an obtuse triangle, whether it's an acute triangle, it will always have two angles that are acute. In this case, here's one, and here's the other. So a right triangle has one right angle, two acute angles. So when they ask us how many acute angles does a right triangle have, it can't have three because one of them has to be right. So it has to have two, because every triangle, no matter what, has at least two acute angles. So our answer should have been H. Now remember, before we do our tests, we do our test taking skills together. Like I told you, that test taking skills, those pictures that we're drawing together that I'm drawing on my paper, you guys can use that to help you on your test. So if I look back, let's see, because I think there was a question about it. So if I look back at my test taking skills, question number 3 had a question about right triangles. And this is something you can use on your tests. Whatever we do for test taking skills, you can use it to help you. Think of it like notes. When we're doing the test, you can always look back at those test taking skills. Look and see, well, what are they talking about? What do they mean? What did we do last time? That might help you out. Yes, this is an example of a right triangle. So you'd have acute, then a right. Okay, question 5. Nakai, you were asking about this one. Frida drew 2 points as shown. So they already showed us 2 dots, 2 spots she drew. She will use a ruler to connect the points and complete her figure. So they told us, after she draws these 2 dots on her page, she takes a ruler, she lines it all up, and she draws another line. So she connects them. Which of the following best describes Frida's figure? Okay, so Nakai, you said that you picked A. Remember, and we talked about this a few times, in math, a line goes on and on forever. And since we can't draw a line forever and ever, because you'd run out of paper, and you really wouldn't just sit there and keep drawing till you were an old man with a giant long beard. When we want to show a line that goes on and on forever and ever, both sides, forward and backwards, we put arrows at the end of it, at both ends, and we can see an example here. An arrow on one end, an arrow on the other. An arrow on one end, and an arrow on the other. But if I look back at this example, this one here, I wouldn't have arrows at the end. I would have points. I'd have dots. So this wouldn't be a line because it doesn't go on and on forever and ever. It stops. It stops on one side and it stops on the other side. It can't be a ray either because rays stop on one side, but on the other side, they keep going on and on. Can't be a vertex. There's no corner. Her example that she drew here would be a line segment. It's similar to a line, but it doesn't go on and on forever and ever. A line segment is like if you took a line and you just cut out a piece of it. So it stops on one side and it stops on the other. So my answer should have been D, a line segment. Remember, that's a very big difference between line and line segment. Lines will have arrows on both sides. It goes on and on forever and ever, one way and the other way. A line segment has to stop both sides. Number 6. 4 lines are shown below, which 2 lines appear to be parallel. I know we talked about this earlier, but who can tell me? What is parallel? When you say that lines are parallel, what are you saying about those lines? Jada helped us out last time. Who can help us out this time? When lines are parallel, what does that mean? What are you saying about those lines? Nakai, what does it mean? When I say that 2 lines are parallel, it means what? Well, if they keep on going, that makes them a line. But parallel doesn't necessarily mean the same. Take a look at the word parallel. They gave us a big clue in there. Look at these 2 L's in parallel. The 2 L's that are right next to each other in parallel are a very good example of parallel line. What does parallel mean? If I say that 2 lines are parallel, what am I saying? They don't have to be very close. Jada, can you help us out again? What are parallel lines? A little bit louder, Jada. They are straight because lines are usually straight. But what is something that they can't do? They can never, ever cross. Thank you for helping us out again, Jada. But the fact that Jada had to answer that same question 2 times in a row tells me that there should have been a lot more of us asking questions. Because we didn't talk about this just one time and then we forgot about it. We talked about this a few times, whether lines are parallel or not, what that means. Kylie. Well, I'm not asking for the answers yet. I didn't ask a question. I thought you just had something to say. Okay. So, they're asking us which of these lines appear to be parallel. Which of these lines look like they will never, ever touch? F says lines M and N. Here's line M. Here's line N. That one I shouldn't have picked because I can see that they cross right away. G says lines M and P. Here's line M. Here's line P. Again, shouldn't have picked that one. I can see they cross right. H, lines N and O. I don't see them crossing, but if I take a look at those arrows and I see the way they're pointing at, I know that right here they're already very close, and if I stretch those lines out just a little bit, they're going to end up crossing. They're going to run into each other. J is lines N and P. If I look at those lines, they're not crossing yet. And even if I stretch those lines out forever and ever, both ways, forward and backwards, they're not going to run into each other. So what answer choice should I have picked here? Kylie? Which one should I have picked, Kylie? J. Okay. For 7, Lena drew an obtuse triangle in her math journal. Okay, since we talked about right triangles earlier, at our example here. Remember, obtuse triangles is a triangle. It's got two acute angles, but instead of having one right angle, what kind of angle do you think an obtuse triangle would have? If a right triangle has to have a right angle, what kind of angle do you think an obtuse triangle has to have? Look at the name, there's a big clue. A right triangle has to have a right angle. So an obtuse triangle has to have what kind of angle? What do you think, Bailey? What do you think, Bailey? If a right triangle has to have a right angle, what kind of angle does an obtuse triangle have to have? I'm not asking what answer choice to pick. Listen to the question. If a right triangle has a right angle, what kind of angle does an obtuse triangle have? Bailey? What kind of angle would it be, Bailey? If a right triangle has to have a right angle, what kind of angle does an obtuse triangle have to have? You're right. So it's an angle that sticks out, but we don't call them out angles. Who can tell me? What do we call those angles? The ones that are bigger, that are open, they stick out. We call those what? Take a look at the name, Bailey. What kind of triangle did they call it? What was the name of it? An obtuse angle. So an obtuse triangle has to have an obtuse angle. If I look at my triangles that they give me here, again, I see that two of them already give me a big hint because two of my triangles have that square in the corner. If I check with my sticky note and I double check those squares, I match up my corners, my vertexes. Triangle A has a right angle. That makes it a right triangle. Girls, what are we typing in the chat for? Let me know when we're finished playing so we can finish going over our math test. Because I would hate to think that we're going over it and people aren't paying attention. That makes this a waste of time. I already know all these answers. I don't need to go over them. Well, it seems like we're not playing with the chat anymore, so let's continue. Answer choice C has the same thing. A triangle with a square in one of the corners. I double check it. The vertex of my sticky note with the vertex of that triangle. And again, it fits perfectly. It's another right angle, which means I have another right triangle. So I don't want to pick A and I don't want to pick C because both of them are right triangles. That leaves me with only two triangles to choose, either B or D. Yes, Ezekiel. And what makes you say B? Okay, so sometimes you can definitely tell just by looking at it what kind of angle you have, but always double check with that sticky note, Ezekiel. Because sometimes when they take an angle and they just tilt it just a little bit to one side or to the other, it might make it seem or look like it's bigger or smaller than it really is. But I like your idea. So you're thinking answer choice B looks pretty good. I'm going to check it. If I check that angle at the very, very top of the triangle, I can see that one side is matched perfectly and the other side is smaller. Ezekiel, what kind of angle do I have where the angle's too small for the sticky note to fit? One of my sides gets covered up. Do you remember what kind of angle that was? What kind of angle do I have if the angle is too small for the sticky note to fit? If one of my sides is covered up. Perfect, it's an acute angle. Now remember, every single triangle has to have at least two acute angles. So just because I found one doesn't mean I know my answer. Okay, we checked the angle at the top. Let's check the angle at the bottom. Put the vertexes together, match them up. And this time, Ezekiel, this time I see that one of my sides is lined up perfectly with my sticky note, but the other side is sticking out. What kind of angle do we have there, Ezekiel, if one side's sticking out? Remember, we talked about 3 different kinds of angles. We talked about obtuse angles, about right angles, and acute angles. What's the kind where one side is sticking out? An obtuse angle. So you were right. You looked at it, you saw, hey, you know what? That looks pretty wide open. I think that might be an obtuse. That's fine. Just make sure you always double check it, okay? So, you're right. Answer choice B should have been our correct answer. Question 8. Look at the trapezoid below. And look what I can see here on this trapezoid. They put one square and another square over here. So they're giving me big hints already. Hey, look. They're telling me what these angles are. What kind of angle is it where I see the squares in the corners? We've seen it a couple times on this test. Alexa? A right angle. So they're already telling me I have 2 right angles here. And it's asking me about the angles. Well, they already told me, and if I double check it, I see they're correct. This trapezoid has 2 right angles. So my answer choice has to say 2 right angles. Answer choice F has 2 right angles. Answer choice G doesn't. So I don't want to pick that. Answer choice H says 2 right angles. Answer choice J says 1. So I don't want to pick J either. So I'm down to 2 answer choices left. F and H. Answer choice F says there's 2 acute angles and 2 right angles. Answer choice H says there's 1 obtuse, 1 acute, and 2 right. So all I need to do is check, and if I find an obtuse angle, I know it's H. If I don't find an obtuse angle, then I know it's F. So I'm going to kind of go in alphabetical order here. I'm going to start with W. I'm going to take my sticky note. I take the vertex of my sticky note, put it in the vertex of that angle, angle W. One of the lines is lined up perfectly along the side of my sticky note, and the other one's sticking out. What kind of angle do I have when one of the sides is lined up perfectly and the other side sticks out? Okay? Obtuse. So I can't pick answer choice F anymore, because it doesn't have any obtuse angles. It has to be answer choice H. Question 9 is asking about perpendicular lines. Now that sounds similar to parallel, but they're not the same thing. Perpendicular lines do cross. And when they cross, there's something special about it. Who remembers what was that thing that was special about perpendicular lines? Alexa, you remember? No, they do touch. Parallel are the ones that don't touch. But perpendicular lines, they do cross. And when they cross, there's something special about it. Chase? What was special about perpendicular lines? It makes a T. So we can think of a letter T, either capital T or lowercase, or we can think about X. Either of them will help you remember perpendicular. But when they make that T or they make that X, they also make right angles. So when you're looking for perpendicular lines, you need to look for right angles. Yes, Ezekiel. And what makes you say that? You're right. This kind of looks like a T if it kind of fell over on its side, right? And they give me a second clue. They put a corner, or they put a box, one of those corners. If I take my sticky note, my trusty handy dandy sticky note, and I match up my vertexes, I see the same thing. It fits perfectly. And when the sticky note fits perfectly, Ezekiel, what kind of angle do I have? What kind of angle is it, Ezekiel, if it fits perfectly in the... It's a right angle. So these lines cross. They have right angles. Answer choice D should definitely be my answer. Answer choice A, they don't even cross. Alexa, what were the kind of lines that don't cross? We don't call those perpendicular. We call those what? Parallel. Now, B and C, they cross, but when they cross, they don't make the right angles. If I take my sticky note and I measure them, these ones, both B and C, they're going to make obtuse angles and acute angles. But the only ones that cross and make the right angles, answer choice D. Okay, number 10. Aaron used a marker and a paper to trace a figure like the one shown below. So he traced this. URSTUV. What statement about the figure is not true? Okay, so they want something that's false. QR is parallel to UV. So Alexa just told us parallel lines never cross. Doesn't matter how long you make them, they never ever touch. If I took the line QR and the line UV, and even if I stretched them out, these two would never cross. They would just be side by side forever. So I don't want to pick that one. That's a true statement. They want something that's not true. G says QR is perpendicular to QV. Just talked about perpendicular. Perpendicular make right angles. I can see that QR, QV touch. And if I check where they touch, if I check it with my sticky note, and I match up the vertex of the sticky note to the vertex of that angle, my sticky note fits perfectly. And if it fits perfectly, what kind of angle is that? Bella, what kind of angle is it? My sticky note fits perfectly. What kind of angle is it? Who can help out Bella? What kind of angle is it if my sticky note fits perfectly? Violet? Right angle. So Bella, what kind of angle is it if my sticky note fits perfectly? A right angle. Well, perpendicular lines make right angles. So that's true too, which means I don't want to pick it. They don't want something true. Line RS is parallel to line TU. Here's RS, here's TU. We said parallel means they never ever touch. And I don't see line RS and line TU touching right now. But what's going to happen if I stretch those lines out? What's going to happen to line RS and line TU if they stretch just a little bit further? Okay? They're going to touch over here, right? And parallel lines cannot ever, ever touch. So this, that's false. Which means That's my answer. Those two lines are not parallel. I could check the last one. Line QV is perpendicular to UV. They touch down here. I take my sticky note. I match my vertexes. I get another angle where my sticky note fits perfectly. That means it's a right angle. Yeah. Almost time for another stretch break. 11. The quadrilateral appears to have, and then they ask us about the sides and the angles. Answer choice A says 2 pairs of parallel sides. If I look at this shape here, do I see any sides that are parallel? No. None of these sides would be parallel. Because if I stretch any of the sides out, they're going to knock into the other sides. So I can't pick answer choice A because the sides aren't parallel. No matter what sides I'm looking at, if I go and I stretch them out, I try to find a parallel side, I'm not going to see one. Because all of them will end up running into each other. If I check B, 2 pairs of equal sides. So that means kind of like a rectangle, how I have 2 long sides and 2 short sides. Does this shape have 2 long sides and 2 short sides? What do you guys think? Is this shape like a rectangle? 2 long sides, 2 short sides? I see Bella shaking her head. No. I have 2 long sides. That part's true. But this side and this side aren't the same. So I kind of have like 2 long sides, a medium side, and a short side. So I can't pick answer choice B. Answer choice C talks about parallel sides again. I can't pick that one. There's no parallel sides. All of them are going to run into each other. Which only leaves one answer choice. D. No equal sides, no equal angle. So even if I look real carefully, if I were to take a ruler here and measure these 2 sides that look like they're longer, this side AB is just a little bit shorter than line AD. So there were no equal sides here. And no equal angle. Yes, Nakai. It does kind of look like a kite, doesn't it? I think the only difference between this and the kites are when they make a kite, they usually have equal sides. And this one kind of looks like someone had maybe like a kite, but then part of it, like over here, I don't know, fell off or got cut off or something. Maybe it got stuck in a tree and it got broken. All right. For 12, which statement is true? So this time they want something true, something not false. A right triangle has 3 right angles. Who can tell me, is that true? Will a right triangle have 3 right angles? So Bella, I see you. No, how many right angles does a right triangle have? Can't have 4. Triangles only have 3 angles. How many right angles does a right triangle have? We talked about this one earlier. It's got 2 acute angles, but it only has 1 right angle. So I know it kind of seems like it doesn't make sense because you would think, well, it's got mostly right angles. That's why they call it a right triangle. But that's not the way it works. Because every triangle has to have 2 acute angles. Has to, no matter what kind of triangle it is. So the first two are always going to be acute. It's the last angle that gives it its name. If the last angle is a right angle, it's a right triangle. If the last angle is an obtuse triangle, it's an obtuse triangle. If the last angle is also acute, then it's an acute. Oh, speaking of, an obtuse triangle can only have one right angle. Is that true? Can an obtuse triangle only have one right angle? Does that make sense? For an obtuse triangle to have a right angle? No, they're not the same. Obtuse angles and right angles aren't the same thing. So an obtuse triangle will not have a right. An acute triangle has all acute angles. We said every single one has two acutes. If it has three, that's what makes it the acute triangle. Answer choice H is correct. An acute triangle has to have all acute angles. Not one, not two, three acute angles. And JJ is also false. There is not a single kind of triangle, no matter what, that has no acute angles. There's always going to be two. Okay, 13. Which polygon does not appear to have two acute angles? This one was all about using my sticky note. If I could use my sticky note, I can find my answer. It says that they want something with that does not have two acute angles. So if I see two acute angles, I know that's not my answer. I want to pick something else. That's all they wanted me to look for. If I check the first one, I go check with my sticky note. The angle up on top is an acute angle. So that gives me 1. If I check the angle to the side of it, I have an obtuse angle. Sorry, not enough. I have an acute angle. Sorry. So I've got 2 acute angles already. And if I check my other angles, I have an obtuse, another obtuse, and a right angle. So figure A only has 2 acute angles. But this one said, the question says which one does not have 2 acute angles. Means I have to go on and check the other ones. I check answer choice B. I'm going to start at the top of the shape. See one right angle. I see an obtuse angle. I see an acute angle, so I've got 1. Another obtuse. And a right angle. There's only one acute angle for answer choice B, and it's this one here. And it looks like a pencil to me, so like at the tip of the pencil. That's the only acute angle there is in that whole shape. Answer choice C also has 2 acute angles. It's got one on either end of this rhombus. So one on the left side, one on the right side. And then answer choice D also has 2 acute angles. Again, kind of at the points here of this. Well, it's a hexagon, but these 2 little points here. The diagonal corner. One acute, another acute. So my answer should have been yes, Nakai.
It looks like a chest.
It kind of does. It reminds me of from the Legend of Zelda games, the little rupees that you get, the money. That's what it looks like to me. Okay, question 14 was the only question on the entire test that wasn't about angles. Just a word problem. A photo studio had a summer photo contest that lasted over 2 months. They received 5,339 entries in June and 7,126 entries in July. Which of the following can be used to find the number of entries the studio received in June and July? We've been working on word problems. I've told you, first things you want to find is your question mark, here at the end, the question word. That lets us know what do they want us to find. Which of the following can be used? They don't want us to solve it. They just want to know how to find it. Find the number of entries. I'm looking for entries studio received in June and July. Okay, so I want to look for entries and I want to look for June and July. A photo studio had a summer photo contest that lasted over 2 months. Did they ask me anything about the number of months? Was that in my question? Was it important to me? No. So I don't need the number 2. They received 5,339 entries in June. Entries in June. So I need to use this number. I need to use 5,339. And 7,126 entries in July. Entries in July. Entries July. So I need to use this number too. 7,126. So people were entering the contest. Some of them entered in June, other people entered in July. What could I do to put June and July together? Figure out how many people are in this contest. Which of my operations will help me put numbers together? Chase? You add them. So let's look at my answer choices. F says to subtract. No. G says to multiply. No. H says to add. Right? And J says to add. Okay, I'm down to 2. Well, I can't pick 2 answer choices. I have to look a little more carefully at H and at J. H says to add 5,339. That was one of my numbers. 7,126. It's the other number. Answer choice J doesn't have the numbers I need. It does have the 5,339. It does have the 7,126, but they snuck in the number 2. The number 2 we said we don't need. So J cannot be my answer. My answer should have been